Students, today we are going to study lens maker's formula. This formula relates the focal length of a lens to the refractive index of the lens material and the radii of curvature of its two surfaces. This formula is so called because it is used by manufacturers to design lenses of required focal length from a glass of refractive index. Now see here some assumptions we follow. Now assumptions made in the derivation of lens maker's formula. The lens used is thin. The lens used is thin so that the distances measured from the surfaces may be taken equal to those measured from its optical center. The object is a point object. The object O is a point object placed on the principal axis. On the principal axis, the aperture of the lens is small. The aperture of the lens is small. All the rays are paraxial, that is, they make very small angles with the normals to the lens faces and with the principal axis. Now you see lens maker formula for a double convex lens. Now see the figure. Let's consider a thin double convex lens of refractive index mu2 placed in a medium of refractive index mu1. Here you see mu1 is less than mu2. Let B and D be the poles, C1, C2 be the centers of curvature, and R1, R2 be the radii of curvature of the two lens surfaces. A, B, C, one surface, another surface is A, D, C. Okay, now you see refraction through a double convex lens. Now suppose a point object O is placed on the principal axis in the rarer medium of refractive index mu1. The ray OM, this ray OM, the ray OM is incident on the first surface ABC. ABC is first surface. It is refracted along MN. It is refracted along MN, bending towards the normal at this surface. If the second surface ADC, if the second surface ADC were absent, the ray MN would have met the principal axis at I1. So, we can treat I1 as the real image formed by first surface ABC in the medium of refractive index mu2. The refraction at surface ABC, this surface ABC, we can write the relation between the object distance U, image distance V1 and radius of curvature R1 as mu2 upon v1 minus mu1 upon u is equal to mu2 minus mu1 upon r1. Let it be equation number 1. But actually the ray Mn here, actually the ray Mn suffers another refraction at surface ADC, this surface, ADC, bending away from the normal at point N. N is here, N. The emergent ray meets the principal axis at point I, which is the final image of the object O. I is final image of object O formed by the lens. Now see, for refraction at second surface, I1, this point, I1 acts as a virtual object placed in the medium of refractive index mu2, and I is the real image formed in the medium of refractive index mu1. Therefore, the relation between the object distance v1, image distance v, and radius of curvature r2 can be written as c v1. Then this small distance is v. Optical center to I, it is v. Now optical center to I1, v1, and radius of curvature, we can write mu1 upon v minus mu2 upon v is equal to mu2 minus once again you see, mu1 upon v minus mu2 upon v is equal to mu1 minus mu2 divided by r2. Put it equation number 2. Now students, be careful for u and v. U and v. Okay. Now adding 1 and 2. Adding equation 1 and equation 2, we get mu1 upon v minus mu1 upon u is equal to mu2 minus mu1 into 1 upon r1 minus 1 upon r2. Or we can write 1 upon v minus 1 upon u is equal to mu2 minus mu1 upon mu1 into 1 upon r1 minus 1 upon r2. On simplification of this equation, we get equation number 3. Now, if the object is placed at infinity, it means u is equal to infinity. The image will be formed at the focus. That is, v is equal to f. Here, see, when the object is placed at infinity, what will happen? The image will be formed at the focus, so that we can write v is equal to f. Now, therefore, 1 upon f is equal to mu2 minus mu1 upon mu1 into 1 upon r1 minus 1 upon r2. Let it be equation number 4. Now, this equation is called lens maker's formula. called lens maker's formula. Now, when the lens is placed at air, means mu1, mu1, mu1. It is, suppose mu1 lens is placed at air. In that case, we will consider mu1 is equal to 1 and mu2 is equal to mu. Then the lens maker formula takes the form 1 upon f is equal to mu minus 1 into 1 upon R1 minus 1 upon R2. From equation 3, this equation, from equation 3 and equation 4, we get 1 upon V minus 1 upon U is equal to 1 upon F. This is the thin lens formula which gives relationship between U, V and F. U is object distance, V image distance, F focal length. See the relation 1 upon V minus 1 upon U is equal to 1 upon F is the thin lens formula, and this formula 1 upon F is equal to mu minus 1 into 1 upon R1 minus 1 upon R2 is lens maker formula when the lens is placed at air. General lens maker's formula is 1 upon F is equal to mu2 minus mu1 upon mu1 into 1 upon R1 minus 1 upon R2. It is lens maker's formula.